Today I want to go over doing a standard minimization problem, and we started talking about minimization problems just briefly in the last class, but I want to go through a whole problem just showing you how to work it. And just remember that you may have to stop the video at some places to enter stuff in your calculator if you're following along, or do row operations when you do the Simplex method. So just remember you can always pause the video at any point so you can keep up, follow along. But here goes. This problem right here is a problem on page 12 of your notes, and it wants us to minimize this problem. Now, the first thing you have to do when you have a minimization problem is get the dual maximization problem, because that's actually what we're going to do the simplex of. I go ahead and start writing my constraints into a matrix. So you can see here that first constraint 1y1, 2y2, 3y3. I went ahead and wrote that as my top row. And do notice, you don't have to put the slack variables in when you do this. Then you write your second constraint, 2y1, 1y1, and 8y3 as 200. The third constraint, I had to put in a 0 for my y2 variable. So just be aware of that. And then equals 50. And then the very bottom row of this matrix, to do the dual max, you just let it be your minimize equation. The y1 plus y2 plus y3. The only thing is, don't make those negatives when you're writing those down. You don't have to have them be a negative. But yeah, this will basically be the matrix that we're going to do something to get the maximum. And I just put some little notes here if you do want to pause the video. But you don't have to worry about doing the slack variables, like I said, and you always make the bottom row positive. Now what we're going to do from this matrix, that was our minimize matrix, we're going to transpose it, which means we swap the rows and the columns. So that first column 1, 2, 1, 1 kind of going down, it's going to be the first row going across 1, 2, 1, 1. And then the second column 2, 1, 0, 1 will be my second row for that matrix, and then so on and so forth from there. You just swap out your rows and your columns, and this will actually end up being the maximize problem, the dual maximize problem that goes with our minimization problem. Now, if you remember, we did simplex method only for maximize problems. So the reason we need this matrix is to be able to do the simplex method to solve our problem. Okay, and we'll show you at the end the connection between the minimize and maximize when we do the simplex. But anyway, this problem asked me to specifically get the maximize equation. Notice when I write the maximize equation, by the way, I write x1, x2, x3. You use x's for maximize, at least that's the trend in the textbook. And then y's are for the minimize. So just so you know, in case you're wondering, why is there x1, instead of y1 or whatever, you switch it over for your max and min problems. But anyway, just going from this matrix right here, the transpose matrix, you're going to get your maximize problem. Okay, you got 3 constraints going across the top, and then you'll have your objective function at the very bottom, the 115 x1, 200 x2, and then 50 x3, and that'll be what we want to maximize right there. Okay. And I'll finish writing this down. And then what I want to do next is actually go into showing you how to do the setup for maximizing, which it's the simplex method. So we've done that quite a bit of times now in class or through different problems. So that's what you want to set up at this point to finish out the problem. So it does say in this next problem down here, take the previous minimization problem in part B and solve it using the duality, which is basically taking the max and solving it with simplex. Okay, and you can read your answers for the minimization problem after you do that. So step 2, I'm basically just going to do the maximize problem. I'm going to take the maximize problem and use the simplex method on this. So right here, what I'm doing is writing my original transpose matrix, but I'm going to put in zeros for my slack variables because I know I will have to have 3 slack variables. So if you can see here, it might be helpful if I write the little. So I wrote the little variables up top here, x1, x2, x3, and then my slack variables, I need 3 of them. I'm just going to take that transpose matrix from above and put in the slack variables for each of the constraints. So you're basically just taking that maximize problem and changing it into the initial simplex matrix. So you want to write down all your numbers here, and then this will be your objective function. Of course, when you write down the initial simplex matrix, you need to make sure you have negatives as from your objective function. So that's one thing different from the transpose matrix right there, like that we use to get the maximize function. When you write this simplex matrix, you want to make those negatives right there. So we have our simplex table right here, and now you're basically just doing the simplex method. If you wanted to pause right here, you could, but I know my first pivot column from step 5 of the simplex method will be, that column right there, that second column, because it has the most negative indicator. And then I want to pivot, if you do the quotients, 1 divided by 2 will give you 0.5, 1 divided by 1 will be 1, and 4 divided by 8 will end up being 0.5 as well. So you can see from there that I'm going to pivot from that top number 2. The step 6 does say to pick the closest number to the top when you have two numbers that are the exact same quotient. So that's what I'm going to use it as, that 2 at the very top, and I'll pivot from that first. And then now I want to start setting up my row operations, and I went ahead and did those on the side. You can see to the right side I have my row operations, so I can get a 0 below the pivot 2. So I want a 0 to be in that spot where that 1 is below the 2. I want a 0 to be where the 8 is, and I want a 0 to be where that negative 200 is. So these are the 3 row operations that I'll do. Of course, I'll save my matrix into my calculator and into matrix A. And then, of course, to do that first, to get that 1 to be a 0, I'll need to divide 1 by 2. Of course, it needs to be opposite signs, so make sure make it a negative 1 over 2. And then, of course, your matrix A. And then, of course, remember that the 1, 2, that'll be the row you're pivoting from, comma, the row you want to change. So that's what my row operations will look like. Now let's go to the calculator, put those row operations in, and show you what that looks like. So you can see here that I put my matrix in my calculator. You can make sure to pause the video if you need to put that in. And then I want to process each one of these row operations. So I'm going to go second matrix and then do math. Go to the very bottom to find those row operations. And you can see me entering them here slowly. You can go through this yourself with me if you want to. But I'm going to do negative 1/2. Matrix A, and then I want to do 1, pivot from row 1, change row 2. And then what I always do here is always check, what did I intend to make 0? Make sure it ends up looking like that on the calculator screen. So, and then you'll go through and do your next one. If it does end up being right, make sure you redo your row operation the correct way till you get the 0 where you want it. So you have to start from the beginning whenever you do make a mistake or whatever. If you're doing it this way, where you keep the answer each time you're using the previous answer. And then I wanted my third row to become a 0 underneath the 2, so I got that. And you can see my mouse is pointing to that. I'm hovering that. That's what I want to happen. I want that negative 200 now to become a 0, so I'm going to do 200 over 2, second answer. I want to pivot from row 1, change row 4, and then I'll end up getting this right here. So I have a 0 on the very bottom, and that's what I wanted. Now I can see kind of my final matrix. Now remember, if you have any negatives in the bottom, you do have to keep doing the row operation, the simplex method. You have to go back to step 5, find the row you're pivoting from, which there's only one negative, thank goodness. It's in that first column, negative 15. So I do want to pick up with pivoting from there, finding my, step 6 is basically figuring out which one I'm going to pivot from. So we want to set that up the best we can. So what you want to do from column 1, since we know we're pivoting from there, is set up your quotients. What I have to do is look on the very side of my calculator and see what the numbers were, which, if I remember, it was 1 was one of the numbers. I think 0.5 was the second number, so 0.5 divided by 1.5. And you can always scroll over there and look to the very far side if you want to. 0.5 divided by 1.5 is 1/3. So, and then, let's see, last, I think I had, what did I have way over there? I had a 0, okay, a 0 on the third row. So it's going to be 0 divided by negative 1. which that's one of the bad. You can't divide by -1. Like if it was 0 divided by +1, it would be okay, but 0 divided by -1 is bad. So I want to pivot basically from this 1/3. It's the lowest. So I will be, or not from the 1/3, but I want to pivot from 1.5. That'll be my number that I pivot from right there. So now we want to set up row operations, new row operations for pivoting from that 1.5 in the first column. So to do that, we want to go onto the side of my paper. That's where I'm going to do it and set up my row operations for that. I want to make there be a 0 right above the 1.5. And one thing I didn't mention is saving your matrix from the previous step into matrix B. So make sure you do store your matrix into matrix B. So that's what you'll be using. And then I want there to be a 0 below the 1.5. So I'm going to have to take 1 over 1.5 because there's a -1 down there. And then previous answer, I want to pivot from row 2, change row 3, and then the very bottom row where the -15 is, I want that to become a 0 as well. So I'll be running this row operation right here to get that to happen. And like I said, after you do your row operations in your calculator, do make sure after each time you press enter that you have a 0 where you want it to. We'll do that on the side. If you feel like you want to use your calculator on your own and do it, feel free to pause the video and if you're following along. One thing I didn't talk about too is when you do store your matrix, your previous one to B, it will overwrite any matrix that you had in there before. So just make sure you're not saving over something you did want to keep. If that's the case, make sure you do it somewhere else, like maybe save it to C or D or E or whatnot. Now you can see where I did my row operations. I have a 0 above and below the 1.5 in that first column. And when I'm looking through my matrix here, I do see that I have a lot of decimal numbers. So I'm going to go ahead and do math and then frac, convert those all to decimal numbers or fraction numbers. So it's a lot easier to read. And basically this is our final matrix right here. If you're doing the simplex method, it'll give you the solution to the maximization problem. Okay, I'm going to go ahead and write that down onto my paper so you can see exactly what's going on. I'm just copying it from my calculator screen, so if you want to do that too, feel free to. And with mine, when I copied it, I went ahead and labeled X1, X2, X3, S1, S2, S3 columns so we could see exactly what's going on with our matrix. And then right here, how do you get the solutions to the minimization problem? Okay, well, the solutions to the minimization problem come from looking at the answers or the numbers at the very bottom of the slack variable column. So when you read off those answers, the answer to Y1, your minimum, will be Y1 will be 95 under the S1 column. S2, that gives you what Y2 would be in your minimization problem. That'll be 10 and then 0. And then your actual min for the answer will be 105. That's the same place you would read the max if you're doing the maximization problem. It's going to be the min for the dual minimization problem that we solved the max for. so basically, going back over the whole process, right? It's about the same level of difficulty for doing a maximization problem. The only real difference is you start with a minimization problem, you transpose it into a matrix, put it in a matrix, transpose it to get a maximization problem that you use the simplex method on to then look at the bottom of the slack variable column to get the minimization problem. So it definitely is something that's a little bit more confusing sounding, but you're basically just doing the simplex method again with a little extra transpose step at the very beginning of the problem. So that's how you end up solving the minimization problems. They're not too much more difficult than the maximization problems. Really, you're just reading a different place, but it is a very cool connection that you can make between the two problems. For every maximized problem, there is a corresponding minimum problem that you can solve. So it's a very interesting connection right there.